Okay, so let's try and prove first that it's monotonic, so that Bn is less than Bn plus 1. So that'd be A1 all the way up to An over n is less than A1 all the way up to An plus 1 over n plus 1. If I cross multiply, I have n plus 1 times A up to An less than n times A1 all the way up to An plus 1. If I expand on the left, I'll have n times all the a's plus 1 times all the a's, up to n that is, less than n times 1 all the way up to an plus 1 here, which uh, uh, um, this one, doesn't quite cancel, so I'll just need to be a little bit careful actually. That's a1 all the way up to an, that's a1 all the way up to an, that's n times a1 all the way up to an plus an extra n times an plus 1 if I split this into two pieces. Now I can cancel this with this. So I just need to show that a1 all the way up to an is less than n times an plus 1. Okay, I think that might be doable. So, okay, let's continue it up the top here. Now this is actually true because we should note that a1 dot 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 all the way up to an will be less than or equal to n times whatever is the maximum element. I mean, that seems fairly obvious. If you take the biggest element here and multiply it by n, that'll be an upper limit here. Now, but note also that an plus 1 will be bigger than whatever the maximum is because it's monotonic. An plus 1 will be bigger than anything here, so it'll be certainly bigger than the max. So then that means that the thing we tried to prove here, it's kind of obviously true, that a1 all the way up to an, that's less than n times an plus 1, because an plus 1 is more than the max, and we have this fairly obvious result that a1 to an will be less than or equal to n times the max. So we've established that it is monotonically increasing, but now we need to show that it's bounded. So I think I'll have to clear this off. Okay, now to show that it's bounded, for all n greater than or equal to 1, an is the absolute size of an is less than or equal to some m, because that's what it means to be bounded. So if we look at what bn absolute size is, note that that will equal the absolute of a1 all the way up to an over n. N is a positive, so it can be brought outside. And because it's an absolute, we can split it. A1 plus A2 all the way up to AN all over N. But each of these guys is less than or equal to M. And that will equal N times M over N, which is equal to M. So therefore, B and is also bounded. n is a natural number, of course. So we've established that Bn is monotonically increasing as well if An is, and it's also bounded, and it seems to be bounded. We can use the same bound, although there could exist a smaller bound, but interestingly we've ended up with the same upper bound here, but it might not be the least upper bound. Anyways, that's another thing to think about in the discussion.